I'm a real geek at heart, and I'm an engineer, I'm a software engineer, and I know it's probably a cliche and it's not, it's naive, but for me is the technology is the problem and it's the challenge. Those are the things that drive me. I can't really give you a good answer as far as where I see the co-op goes and where it would be next year, 5 years, or 10 years from now. But I can tell you this, that there is power in doing things the way we do. I've been doing this for a long time, and I can tell you this is the happiest I've been in a very long time in my career. I do very interesting projects. The pressure of deadline is still there as if I was working for any other enterprise. Those things haven't changed. But what has changed is that we all work together, and if I have a problem, I just ask. And there is not one, but two, and maybe 10 that just jump in and help me. I mean, we've been around here for the last 2-3 days. I worked with developers that I hadn't seen before, but they all knew that Kayvan has this problem. So, as I sat at my desk, trying to work out my problem, I see people coming into me that I hadn't seen before. But somehow they had heard that I had this problem, so everybody was coming in. And it was great. It was really great. We were able, in the matter of 2-3 days, to change the code base for our node, which is thousands of lines of very, very complicated code. It's a program that writes other programs that write other programs. So it's not an easy task. But because we're such a group and we really like what we do, everybody just jumps in. I mean, in reality, they're in a conference. They should be worried about their presentations and the work that they came here to do, but instead they're staying up later to get prepared. But come and help me, and I think that's where the co-op is. I think that's where it's going, and when you have a momentum like that, you go far. As far as the plantoid goes, I was tasked with developing an algorithm and deploying code base R node into Raspberry Pi. R node is not designed to run on something as small as a Raspberry Pi, but the challenge was to show a proof of concept that we could deploy a validator in any environment, something as small as a Raspberry Pi, and then be able to interact with that deployment. So in case of this particular project, it turned out that we wanted to be able to generate music based on sensor data, which pretty much boils down into collecting that sensor data from a variety of sensors that we attach to Raspberry Pi in this case, and Raspberry Pi 3B. Push those sensors into our node, which is form of our blockchain implementation, and then turn around and get that data back and feed it into a number of algorithms which basically generate digits of pi and digits of natural log, and then turn those into music. That was the extent of the project. The challenging part was deploying this ongoing development of our node into a Raspberry Pi. From the very beginning, it was pretty apparent that I couldn't use the most common OS that comes with Raspberry Pi, which is the Raspbian. Unfortunately, right now, only the 16-bit version of it is available. Some of the libraries that we use for encryption and for persisting into memory have a very strict requirement of a 64-bit architecture. So for that reason, I chose OpenSUSE OS. It's a wonderful product that made the job a lot easier for me. I did have to make some modification. I ended up basically building a lot of the crypto libraries that are required into the Pi. So if you can imagine, this little box is building Google Protobuf, is building crypto libraries. So it was just constantly going on for 2 days in a row before I could get all the libraries built there. From that point on, it was a matter of hacking the Java class path that we have for our node. It is a JVM-based application, and have it point to these newly built libraries on this ARM architecture. Once that was completed, then it was a matter of developing the algorithm for generating the music, and finally being able to harness that data from the blockchain. The tool of choice that we use is Google gRPC. So basically we end up having listeners that are on the block and deployed into the Raspberry Pi, attached to a USB port to a 3 gig storage device, and pushing the sensor data in there. And on the other side, making gRPC calls and basically listening for names. In the RNode world, everything surrounds names and the data that comes in and out of those names. So get the sensor data from those names, bring them in, crunch them, and finally generate the music. It was a really, really cool project. That's a very good question, and the answer is both. In order to interact with our node, you need to write contracts. Those contracts are written in Golang. However, in order to be able to interact with the outside world, you need to have a different language. This project could have been done in Python, in JavaScript or Node.js, in C, C++. It could have been written in any language. It just turned out that our code base for our node is Scala. I've been doing Scala for a long time. It seemed like a natural fit. It's a language that I can go and ask developers of our node, hey, I'm seeing these problems, I'm seeing this, let's see what I can, is it something that I'm doing different? Do I need a different plugin for this? So it made things easier to just stay with Scala, plus the fact that I'm a Scala developer. Good question. So the algorithms, they came from Greg. I cannot take credit for those. The idea is that he described it to me really well, and I know I'm not doing justice, but there is actually a correlation between pi and natural log and music notes. So the idea was, without having to walk through and compute all digits of pi before you get to, for instance, the second or the third or the 100th of them, have an algorithm that says, hey, I want a streaming pi digits, and I'm interested in going into and grabbing the 10th one and the 100th one and the 1000th one, but I don't necessarily want to compute all these when I need them. I want them pre-computed in a stream, and then I want to pick. So if you can imagine, in an environment like Raspberry Pi, that saves you a lot of processing power when you need it. And so that's the algorithm, and it is written in Scala. That came to me. He had already added, I basically had to get that, wrap it up into a format that I can use within that paradigm that I described earlier, making the gRPC calls basically. And at the same time, kind of change some of the variation of that algorithm. Instead of coming up with digits of pi, come up with digits of natural log. I can tell you this: it's the gateway drug. Once you start doing Roland, you just want to remain in that paradigm. You just want to do things that way. For those of us who've been around this this thing for a while, doing concurrent programming and computation is just painful, no matter what language you pick. It's painful. It's gotten better, with some of the functional paradigms that we have started using, but it still is not easy. And here comes Roland, where by default everything is concurrent. It's you put P bar Q, and then you have two things that are occurring concurrently. I mean, how easy is that? If doing that in other languages is just not as easy. So I guess I don't have a short answer for you.